Hey, it's Mrs. Bat here. Today we're going to be talking about one of my favorite shapes in the whole world, and that's the rectangular prism. All right, when you look at these, now games are a great example. My family loves to play games, but they all come in a box, which mathematically we call a rectangular prism. All right, so let me get some of these out of the way so we can talk about it. So some key features we want to talk about with rectangular prisms is that they're made of rectangles. So everywhere you look on a rectangular prism, you will see a rectangle, which is a lot different than the shape we talked about last time, which was cylinders that had circles on it. And of course, when we unrolled the cylinder, we got a rectangle, but when it was all rolled up, it was not a rectangle. It was a lateral surface, and we had to take time to flatten it down, okay? But in a rectangular prism, everything is a rectangle. And so if we were to cut this box apart, everywhere that we have an edge, we would end up with a bunch of rectangles that we could lay out, okay? And so what we're going to be talking about today is the surface area of a rectangular prism. And so I want you to imagine that you are going to cut it apart, and we're going to lay out all the rectangles and find the area of those. Super easy to find the area of a rectangle, and then just add them all up, okay? And you may be thinking, well, why? Well, think about it. The manufacturers of all these products, I mean, here's something else that comes in a box. I've got some pasta here. Lots of things come in boxes. And so if you think about the manufacturers who create these boxes have to have a plan, an idea of how this box is going to fold up from what they create out of flat cardboard. So we're going to kind of take the first steps toward that. So let me put the games away. And I have a box here, okay, that has already been flattened out. So this would be what it looked like before it got put together, okay? And as you can see, it's got all the folds, okay? So if we were to fold it all up, right? Oh, what have we here? Honey Nut Cheerios, okay? So you can see, now the interesting thing about like a box like this is it's got some extra space. I don't know if you can see where I ripped it apart where the glue was. So there's going to be some overlap, obviously, that a manufacturer would think about. So for example, like when you fold this in, these flaps like overlap each other. Now what we're going to be doing today, we're not going to be overlapping. We are going to be doing the very basics, basically cutting the edges, okay? So no overlapping parts, but understand that in a real life situation, you might want overlapping parts because that gives us the place to glue that back together. Okay, here's another example. It's a little bit smaller net, and you can see that this one's even got some angles in it to help with cutting down probably on production costs. So if we were to put this all back together, you can see like on the edges, these flaps go here. And then you can see the ones that close over are the ones that have the little angles. So you see there's some overlap there, and that kind of is a design thing. But again, today we're just going to be looking at the straight as if we were to cut it on the edges exactly and then stick those pieces together, okay? So I want to talk to you a little bit about that. All right, so I'm going to start with my pasta box, and what I've made a net already, okay? And so the job you're going to have today is you're going to see a picture of a box. And what's a little bit tricky is it's one thing to see a 3D box in person and be able to be like, okay, I can see the front, I can see the back, I can see the sides. And if we were in class together, that would be really cool. So I'm glad you're watching this video, because the hard part is you're going to be seeing a picture on a box on flat paper that's going to be drawn in perspective, and you have to be able to look at that and be able to kind of visualize what its 3D shape is in your mind and then cut it up from there. And sort of the easiest way that I have found, and you know, obviously I think I'm great, hopefully you think so too, I have found the easiest way for most students to do this is to basically set it down or imagine it being set down and then slice the corners and basically peel it like a banana. Okay, so that's the way I teach it. Other teachers, if you Google this and look up some videos about surface area nets online, you will see other teachers have different methods. I think it's easier to just sort of see what I have and then peel it one piece at a time. So let me show you what I mean by that. Okay, so I've taken some white paper and completely covered my pasta box. Okay, and then I'm going to start cutting it here. And basically I'm going to peel the top up, and I want to kind of ignore the top right now because there's a lot of different things we can do to the top. Right now it's attached to this side, so I'm just going to tuck it under. And right now I'm really going to focus on the front, the back, and the two sides. Okay, so imagine you're looking at it here. The first thing we're going to do, we're going to basically plant it, and we're going to draw that rectangle that's on the bottom. Okay, so let me hold this a different way. I'm not coordinated enough for this. So anyway, you're going to draw the bottom. There it is on your paper. Now I want you to imagine if you slice it and you peel it. So if you peel the side down, it's going to be a rectangle that's basically attached right to that bottom. Okay, and then you're going to peel the other side down, and that side is going to be the exact same as the one over here, isn't it? This rectangle and this rectangle will be exactly the same. Okay, if we peel the front down, now notice that rectangle is a different size, and then peel the back. Okay, and then I'm going to go ahead and take the box off because the base that it was sitting on. And so once you draw the bottom and then the four sides, you're going to end up with a cross. Okay, and what I want you to really pay attention to, and this keeps falling apart, is that you have four L's that I want to really pay attention to. So do you see, let's stack this right, this L here that's formed by, it's a backwards L, I guess, probably, or to me it's a backwards L, maybe to you it's forward. This L here, because the height of the box, remember these both were coming from the height. So what I'm looking at right now is I'm looking at where we cut it here, okay, and we peeled the front down and we peeled the side down, okay, and that's what I'm talking about right here. And this side, this measurement here and this measurement here are the same because when they folded up together, remember they hit that corner of that box, okay, and you're going to have that exact same L on all sides of your cross. So you're going to have the same measurement here and here, here and here, here and here, and here and here, okay? And then notice I've kind of folded my top in, and right now I have it stuck on a side, okay? But really that top could have gone anywhere. Okay, so I went ahead and cut the top off so you can see basically I'm going to end up with a cross, which is made of the bottom of the box, two sides, and then the front and the back. And again, we have these L's that are the same size. Now, what I want you to notice as you look at this, do you see that this side piece here and this side piece over here are the exact same size? But the base piece in between them is not. Now, if you have a square or a cube, then you may end up with pieces side by side having the exact same sizes, but most boxes, you will never have the same size rectangles next to each other, okay? Because this is the side, it attaches to the bottom, which then attaches to the other side here, okay? And then if you notice, see, take a look, okay? So there was the bottom, and then the side, and then the side, and then the front and the front, okay? And you can see that the front and the back are opposite the bottom here, and they are also both the same size, okay? So I really want you to visualize this. Now, the next thing I want to talk about is how many sides there are, okay? And I'm calling them sides because when I think of it as a box, I think of left side, right side, or left side, right side, depending on which way you're looking at it. But technically, the word for those is faces. And so when we talk about a rectangular prism, it has 6 faces. So that means 6 rectangles. So when you look at your net, for example, I told you I already cut the top off here. This is not complete. When I have just the cross part, it's not done. And that's where a lot of kids sometimes don't remember to draw the whole thing. Remember, you have a bottom, a top, a front, a back, and a side and a side. So you will have 6 rectangles basically in 3 pairs because your top and your bottom will be the same size rectangle. Your side and your side will be the same size rectangle, see? And then your front and your back will be the same, okay? So really, really important to pay attention to that. Now, remember I told you this top piece, okay? And again, as you can see, it's about the right size, and it will be the exact same as what you had in the center of your cross, okay? But the key thing is it can really attach anywhere, okay? So depending on how much space you have, that's the hard part when you start drawing this on paper, is sometimes students get started drawing and then they run out of room on one side because they're still trying to physically figure out where to draw and they run out of room. So let's say you run out of room and you were going to put the top over here. Well, guess what? It could attach up here, couldn't it? Okay. So if you were to imagine it like that, okay, so I would have that top, if I cut it, I could have it attached to the back. It could attach right here to the side, okay, and if we were to do that, you see we'd have my cross, and then I would have an extra piece over here that's the same as the bottom, okay? So remember, the top and the bottom will always be separated by either a side piece or a front or back piece. So before you start calculating your surface area, stop and check. Do I have 6 rectangles? Do I have 3 pairs? Do I have a bottom and a top wherever I stuck it? Okay. Do I have 2 sides, and do I have a front and a back? Okay, so in the next video, we're actually going to practice that, but I really wanted you to see, and it may help you as you're doing your homework to maybe have a box of tissues, a box of pasta, toothpaste, some kind of box with you to help you remember all of this and what it really looks like in person. Okay?